Hello everyone, welcome to another episode of our design pattern series here at Code to Commerce. I am Mayank Pratap Singh and today we will be diving into the factory design pattern. So what exactly is a factory design pattern? Well, imagine you are at a car dealership. You need different types of cars, either sedan, SUV or a sports car. You tell the salesperson what kind of car you want and they will arrange it for you without you needing to know how it's made. That's how the factory design pattern comes in action. But why do we need this pattern? Imagine you are building a software system that needs to create different types of vehicles based on user preferences or configuration. Instead of cluttering your code with complex vehicle creation logic, you can use the factory design pattern to delegate this responsibility to a specialized class. Let's consider a problem statement. Suppose you are developing a simulation game and need to create different types of cars, sedan, SUV and a sports car. How do you create these cars dynamically without cluttering your code? The solution lies in the factory design pattern. We will create a car factory class that contains methods to create different types of cars. This way, our code remains clean and organized, and we can easily add new car types in the future as well. Now, let's dive into a code implementation using the same example. First, let's take a look at some incorrect code in Java. Please do not focus on Java here. Instead, focus on the implementation. The implementation is completely language agnostic. Here, we have this implementation where car creation logic is scattered throughout the code. What do you think is incorrect here? Let me tell you. In the car class, we define properties such as model and type, representing characteristics of a car. Additionally, the car includes a method createCar, responsible for instantiating different types of cars based on provided parameters. Also, a displayCar method is implemented within the car class to showcase the details of the created car object. To demonstrate the functionality of displaying a car, the incorrect car demo class utilizes the displayCar method defined in the car class. Now let's talk about the problems here. Violation of single responsibility principle. The car class is responsible for both representing a car entity and creating instances of cars. This violates the single responsibility principle, which states that a class should have only one reason to change. Combining entity representation and creation logic makes the class harder to understand. Lack of flexibility and scalability. The hard-coded creation logic limits the flexibility and scalability of the code. Inefficient code reuse. The creation logic is repeated within the createCar method for each car type. This violates the DRY principle, don't repeat yourself, which leads to inefficient code reuse and increased maintenance. Now, let's fix this with the factory design pattern. In this setup, we have different types of cars like sedan, SUV and sports car. Each car has its own characteristics like model and type. To create these cars easily, we use a special helper called the car factory. It's like a machine that knows how to make different types of cars based on what we ask for. The car factory takes in information like the car model and the type we want and then gives us the right car. So if we ask for a sedan, it gives us a sedan. If we ask for an SUV, it gives us an SUV, and so on. This way, we keep things organized. The car factory handles the job of making cars, while each type of car just focuses on being itself. It's like having a separate team for building cars so everything stays neat and easy to understand. Now, let's talk about the benefits. Abiding by single responsibility principle. The car factory class encapsulates the creation logic, separating it from the car class. This adheres to the single responsibility principle, as each class now has a single responsibility, creating instances of cars or representing a car entity. Flexibility and scalability. Adding new car types or modifying the creation logic can be done within the car factory without impacting the car class. And there you have it. The factory design pattern simplifies object creation by delegating it to a specialized classes. Please subscribe, like, share and hit the bell icon to stay updated with the latest videos. See you in the next episode.